In this video, you're going to learn how to work with complex numbers as well as imaginary numbers, and we're going to do some basic operations like adding, subtracting, multiplying, and dividing complex numbers, as well as working with i's to a higher power and solving for zeros involving complex numbers, and some other common problems that you're going to encounter when you first start working with complex numbers. So let's dive into this video. First off, what exactly are complex numbers? Well, complex numbers are a combination of real numbers and imaginary numbers. And when we think of a complex number in standard form, we think of it in this a plus bi form. The a is like the real part and the bi is the imaginary part, and together it forms a complex number. So the main thing you want to remember is when you see I represents the square root of -1. And when you see I squared, that's going to equal -1. So for example, if you wanted to take the square root of like -16, remember when you take the square root, it's asking us, what number times itself equals -16? Well, we know that 4 times 4 is positive 16. -4 times -4 is also positive 16. So how is it that we can multiply the same quantity times itself and get a negative number? That's where I comes in. So for example, here we could write this as -1, the square root of -1, times the square root of 16. And the square root of -1, that's represented by I, and the square root of 16 is represented by 4, because 4 times 4 is 16. So this works out to 4i, and you've got it. So that's where square roots, that's where imaginary numbers come into play when you take the square root of a negative number. So let's dive into some examples, and you can see how this works out. So for number 1 here, it says find the square root, and this is the square root of -18. So you probably already know how to simplify radicals. It's the same idea, but what you can do is you can write this as square root of -1 times square root of 9 times square root of 2. See, all that multiplies to -18, but the reason that I broke it up in this way is because, see, square root of 9, that's a perfect square, that's 3. Square root of -1, that's I, and then the square root of 2 we can't simplify, so that stays underneath the radical. Now, sometimes students will ask, like, do I put the I in front of the square root, or do I put the I like over here? It really doesn't matter because multiplication is commutative, and sometimes, people will like to write it like this, like 3 root 2 I, but what happens if you don't have the parentheses, sometimes it looks like that I is underneath the square root, and so it kind of causes a little bit of confusion, so that's why oftentimes it's written in front of the radical like that, just so it doesn't look like it's underneath the radical there. Okay, so that's for number 1. So for number 2, see if you can do this one. We have 3 square root of -48. Well, of course, when these are right next to each other, that means that they're multiplied together. -48, we can write that as, well, let's write this out. We've got 3 and square root of -1 times square root of 16 times 3. Now, if you don't like this method, you could take 48 and just break it down. You could say this is like 8 and 6, this is 4 and 2, this is 2 and 3, this is 2 and 2. And then what you're doing is, since you're taking the square root, you're looking for pairs, like 2 of the same number. So this would represent 2 times 2 is 4 with a 3 left over, okay? But because it was a square root of a -48, this is going to be 4i root 3. Then multiply by this 3 here, which would give you 12i root 3. So that's one way of doing it, just breaking it down into prime factors. The other way here is just to try to divide out perfect squares, like here, square root of 16 is 4, times this 3 is 12. Square root of -1 is I, and then we have that square root of 3 left over. Either way, you can see you're getting the same result. So whichever method you prefer, go with that method. Now, let's go over to adding and subtracting complex numbers now. Okay, so here what we're doing is we're trying to add these two complex numbers together. You can kind of think of I as like a variable, like X or Y or Z. And what you're doing is you're combining like terms. So you could say 2 plus 3, that's going to be equal to 5, right? And -3i plus -7i, that's going to give us -10i. And you got it. You always want to put the real part first, see A, and then the imaginary part second, that's your BI. Let's go down to number 4 now. Here you're subtracting. Now with subtracting, sometimes it gets a little bit confusing, and what students sometimes like to do is think of this as subtractions like adding the opposite. So whatever's in the parentheses, I flip the sign. Or you can think of that negative as like a -1 and you're distributing the -1 into the parentheses. So just think of a subtraction as like adding the opposite or multiplying by -1. Now when you combine like terms, -3 plus -4 is -7. 2i plus 6i gives us 8i. And now you can see it's in the complex standard form, a plus bi form. Okay, let's talk about multiplying and dividing now. So it's just like when you multiply with variable expressions, you can think of I as a variable like x or y. And so what you're doing is, here you can see we have 6i times the quantity 2 minus 8i. So you have an imaginary number times a complex number here. You can think of this as just distributing into the parentheses, and you're multiplying like terms together. So for example, you have 6 times 2 is 12i, just like as if you were multiplying 6x times 2, so that's 12i. And here we have 6i times negative 8i, which is negative 48i squared. Remember, when you multiply and you have the same base, you add the exponent. So this is like 1 plus 1 is 2. But remember, what's I squared equal to? Negative 1. So this is like negative 1 times a negative 48, which is positive 48, plus the 12i, and now you have it in the standard form, a plus bi form. Let's try number 6. So number 6, we have a complex number times a complex number, and you can think of this as like a binomial times a binomial. And so when you do that, you have to FOIL, or you can think of doing the distributive property twice. So let's do that. So 5 times 5 is 25. 5 times 2i is 10i. Then if we take the negative I and distribute, negative I times 5 is negative 5i, and negative I times positive 2i is negative 2i squared. Now remember, I squared is negative 1, so negative 2 times negative 1 is positive 2, plus the 25, that's 27, and then here the 10i minus 5i is a positive 5i, and you've got it. So just remember, I squared is negative 1. And now for dividing, number 7, we've got 7 divided by I. So when you're dividing, you don't want to have an imaginary number in the denominator. You don't want that I in the bottom. So what you want to do here, when you just have a monomial, just like an I like that, or if it was like 2i, 3i, just like a one term here, you just have to multiply the numerator and the denominator by I, or I to the first, okay? Anything divided by itself is equal to 1. See, I divided by is 1. So 1 times this fraction is not going to change the value of the fraction. It's just going to change the way that it looks. So 7 times I is 7i. I times I is I squared. But we know I squared is negative 1. So this becomes 7i divided by negative 1, or you could say negative 7i. And we've gotten rid of that I in the denominator, which is considered improper. For number 8, though, see the I in the denominator here? We don't want that I in the denominator, but here this is like a binomial, right? It's like two terms. So here what we have to do is we have to multiply by the complex conjugate. What does that mean, complex conjugate? It means these two terms are the same, but you're just changing that sign in between. So you don't want to flip all the signs, just the sign in between. If this was plus, I would make this minus. Again, whatever you multiply the denominator by, you want to multiply the numerator by, because anything divided by itself is 1. So multiplying this by 1 doesn't change the value. So let's go ahead and distribute. So that's going to give us 2 times 3, which is 6. 2 times I is 2i. In the denominator, we have 3 times 3, which is 9. 3 times I, which is 3i. Negative I times 3 is negative 3i. And negative I times positive I is negative I squared. Notice that the 3i and negative 3i cancel. I squared is negative 1, right? Times this negative makes it a positive 1. So negative 1 times negative is positive 1, plus 9 is 10. So now you can see we've gotten rid of the I in the denominator, which was considered improper, by multiplying by that complex conjugate. But you don't want to stop here, which sometimes students do. They say, okay, I'm done. You want to rewrite it so that the imaginary number and the real number, those parts are separated. And so the way you do that is you split this up into two fractions. So this is really like 6/10 plus 2/10 I, okay? And then you can reduce that a little bit further. So 3/5 plus 1/5 I. That's your A plus BI form, your standard form. Okay, for number 9, a little bit more challenging. See if you can do this one. Again, we have that I in the denominator, which is considered improper. So we're going to multiply by the complex conjugate, so 2 minus 3i. So here we're going to do some foiling. Okay, so we've got the first, 4 times 2 is 8. We have the outside, that's going to give us negative 12i. We have the inside, which is 2i, and we have the last, which is going to give us negative 3i squared. And then over here we have 2 times 2, which is 4. The inside and the outside cancel. 6i and negative 6i cancel. So then the last term, negative 9i squared. But we know I squared is negative 1 times the negative 9 is positive 9 plus 4 is 13. And in the numerator, let's see, we've got I squared is negative 1 times negative 3 is positive 3 plus 8 is 11. And negative 12i plus 2i is negative 10i. And then like we said, we want to split this up so that the real part and the imaginary part are separate. And that's your final result. So the nice thing about multiplying by the complex conjugate is that these inner and outer terms are canceling. So you just get that first and last, and that's what gets rid of the I for you. Okay, number 10, this one we have a binomial squared, right? 4 minus I squared, or a complex number squared. What you don't want to do, this is what some students will do, they'll say, well, Mario, can I just distribute this 2 and say 16 minus I squared like that? Well, no, because really it's 4 minus I squared. It really means it's 4 minus I times another 4 minus I. So it's this multiplied by itself. And then because it's a binomial times a binomial, you have to distribute twice, or if you know the FOIL, you can use the FOIL method. So let's do that. So 4 times 4 is 16. 4 times negative I is negative 4i. Negative I times 4 is another negative 4i. And negative I times negative I is positive I squared. Of course, we know I squared is negative 1. Plus 16 is 15. And then these two add up to negative 8i. So that's your A plus BI form. And you got it. Okay, great job for sticking with me in this video. We're going to dive into some different types of problems that come up when you're working with complex numbers. So let's go through some of these. We've got 2x squared minus 4 equals negative 44. We want to solve for x. It's just like solving a normal algebra equation. You want to get that variable by itself on one side of the equation. So we're going to do that by adding 4 to both sides. Okay, so now we've got negative 40, and this is 2x squared. We want to divide both sides by 2 to get that x squared by itself. So that comes out to x squared equals negative 20. Now we just want to take the square root of both sides. That's plus or minus square root of negative 1 times square root of 4 times square root of 5. Square root of negative 1 is I, square root of 4 is 2, and square root of 5, and this is plus or minus, and those are your two solutions. So again, just like solving a normal algebra equation, remember when you take the square root of both sides, you get the two answers, and when you take the square root of a negative number, that's where the I comes into play. So for number 12, same idea here. It says find the zeros of this function. Well, when they say find the zeros, it means find out what's going to make this whole equation equal to 0, or graphically, finding the zeros means you're finding the x-intercepts where it crosses the x-axis, and that's where the y value equals 0. H of x is like y. So we're going to set that equal to 0, and we're going to solve. So we're going to subtract 27 from both sides. Negative 27 equals 1/3 x squared. We're going to multiply by the reciprocal, 3 over 1. So that comes out to negative 81 equals x squared. And if we take the square root of both sides, x comes out to plus or minus 9i, because we have the square root of negative 81. That's the negative gives us the I. Square root of 81 is 9. And we take the square root of both sides, we get the two answers, positive or negative. Okay, for number 13, this is a little bit different problem. We didn't talk about this when we were talking about multiplying. But what some students is, they'll say, well, Mario, isn't this square root of 32? And I can just simplify square root of 32. Well, if you do that, you're going to get a little bit of a different answer. What you want to do is you want to simplify this first. So for example, square root of negative 8 is really like square root of negative 1 times square root of 4 times square root of 2. This gives us I. Square root of 4 gives us 2. And then this gives us square root of 2. That's the remainder. Over here, square root of negative 4, square root of a negative, we get the I, right? Square root of 4 is 2, so that comes out to 2i. Now when we multiply these together, we get 4i squared times the square root of 2. So I'm just multiplying the numbers, the i's, and then the square root. So like multiplying like terms together. I squared, though, gives us negative 1, so that comes out to negative 4 square root of 2. See, if we were to simplify this just by multiplying and saying square root of 32, that would have been positive 4 root of 2. So that's why it's important you want to simplify these first before you multiply them together. Okay, so for number 14 and 15, these ones kind of go together. This is what I call like I to like a higher power as opposed to just like I to the first or I to the second. So there's two different ways to look at this problem. I'll show you both methods and you can pick which one you like. But most students, or I should say maybe me, I like this method because it's less to memorize. I like to say how many times does 2 go into 23? It goes in there 11 times with 1 left over. See, because power to power you multiply, that's 22, and then when you multiply you add, so 22 plus 1 gives you 23. And the reason I do that is because we know I squared is negative 1, and a negative 1 to an odd power, that's like a negative 1, negative 1, negative 1, 11 times, so negative 1 to the 11th power is negative 1, times I just gives us negative I. So then you're saying, well, what's the other method? Well, the other method, you can memorize that I to the first is I to the second is negative 1, I to the third is negative I, and I to the fourth is 1. And it just repeats. So this would be I to the fifth, I to the sixth, I to the seventh, I to the eighth, etc. So here we'd say, well, 23, 4 goes into 23 how many times? 5 times, remainder 3. So it's like going through this 5 times, okay, and then remainder 3, 1, 2, 3, see negative I. So that's how it works. Let's do number 15. You'll see, so I to the 68th, that's really like I squared to the 34th power, because power to power, those multiply to 68. I squared we know is negative 1, and a negative to an even power, like negative 1 times negative 1 34 times, that's going to be a positive 1. Over here, if we use this method, we say, well, how many times does 4 go into 68? Well, 4 goes into 6 once, and 4 goes into 28 17 times. Remainder is 0. Okay, so it's like going through this cycle 17 times, and then remainder 0 means it's going to be 1. If it was remainder 1, it would be I, remainder 2, remainder 3. This is no remainder. So if you want to memorize this, go ahead, or just think about I squared. How many times does I squared go into this? And that's another way to do it. Okay, number 16, we've got x squared minus 2x plus 2 equals 0. How do we solve this equation? Well, because we have a squared term and x to the first term, we could either try to factor this and set the factors equal to 0. In this case, it's not factorable, so let's go and use the quadratic formula. So remember the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So in this case, a is 1, b is negative 2, and c is positive 2. So let's put that in. So negative b would be negative times negative 2 is positive 2, plus or minus the square root of b squared, which is negative 2 times negative 2 is 4, minus 4 times a, which is 1, times c, which is 2, all divided by 2 times 1, which is 2. So this comes out to, let's see, we've got 4 minus 8 is negative 4. And we know the square root of negative 4 is 2i. So we have 2 plus or minus 2i divided by 2. And then what I'm going to do is I'm going to divide both these groups by 2. So that's going to be 1 plus or minus i. Or you could write it as 1 plus I and 1 minus I. So I wanted to split it up because I wanted it to be in that standard form, a plus bi, the standard form of a complex number. So if you can't factor, do the quadratic formula. And remember, if you take the square root of a negative, that's when the I comes in. So let's go down to number 17 and 18. These ones are similar. It says find C and D. And what we have is we have a complex number equal to a complex number. We have 3 plus CI equals D plus 7i. So how do we solve that? Well, what you can do is you can set the real part equal. So here you can see D is equal to 3. And then you can set the imaginary part equal. So CI equals 7i. So that means that C must equal 7. So that one was kind of easy, but a little bit more challenging. Number 18, here we have the real part. 5c is equal to 2. So divide both sides by 5. So you can see that c equals 2/5. And here we set the imaginary part, 12i, equal to negative 8di. So you can see the i's, those are the same. So it's really just negative 8d equals 12. And divide both sides by negative 8. So d equals negative 12/8, which reduces down to, let's see, that would be 4 goes in here 3 times, and 4 goes in here twice. So you're just setting the real part equal and the imaginary part equal. And then for number 19, this one's a little bit different problem than what we've seen. This is called finding the absolute value of a complex number. And there's a formula here that you can memorize. But what I want to show you is that you can actually plot complex numbers in the complex plane. What does that mean, the complex plane? Well, this is like the real number line, and this is like your imaginary number line. So for example, if I wanted to plot 3 plus 4i, I'm going 3 along the real direction here. 4i, I'm going 4 in the imaginary direction, this vertical direction, and that's how you plot the complex number in the complex plane. So real, imaginary. But when you're taking the absolute value, what you're doing is you're finding that distance of that point from the origin here. And you can see that this is like a right triangle here. See how this is 3 and this is 4? So it's like a squared plus b squared equals c squared, like the Pythagorean theorem. And so that's where this formula is coming from. You can see that this is going to be 5, and that's your answer. Or if you want to use the formula, this would be 3 squared plus 4 squared, and then take the square root, which is 9 plus 16, square root of 25, which is equal to 5, and you got it. If you want to see more videos and some more advanced videos involving complex numbers, follow me over to that playlist right there where I put all my complex videos together, and you can see which ones you want additional help on right there. So I'll see you in those videos.